Okay, so to find this indefinite integral, we'll go term by term because the integral operator is a linear operator. um, that's a terrible 2. That's supposed to be squared. So we know the power is supposed to go up when we're using an antiderivative, but we've got to fix it so that when we take a derivative, this would turn back into 2x squared. Right now, it would be 3x squared. So I can fix that by putting a 2 and dividing by 3. Now when I take a derivative, the 3 cancels out with this 3, and we're left with 2x squared because the power reduces by 1. Okay, we'll do something similar here, except watch out, you're still adding 1. That should be negative 2 for the new power. But if I take a derivative right now, that's going to give me positive 8x to the negative third. The power is right, the coefficient is not. So let's change this to be the opposite sign. That way when the negative comes down, multiplies, we'll get our negative. But it's not supposed to be negative. It's not supposed to be negative 8 when we're done. It's supposed to be negative 4. So we can compensate by making this 2 here. Okay? So negative 2 times 2 makes negative 4x. And then the power would reduce by 1 to be negative third. So this is positive 2x to the negative second is the antiderivative. And then for this one, you just have to remember the derivatives of trig functions. The derivative of tangent x is secant squared x. So that's not going to be it. We're working in reverse. The derivative of secant x is secant x tangent x. That's it. Secant x is the antiderivative of this term because the derivative of secant of x is secant of x tangent of x. And then the last thing is plus some arbitrary constant c. Okay, and I think that's everything.